All right, our first step for putting on these wheels and motors, mounts, and all that is let's put some components in. So let's go to Place. Under Place, let's go to, first off, let's go to our Motor Mounts tab, or folder, and let's place in the 37 millimeter bottom tapped motor mount. 37 millimeter bottom tapped motor mount. Place in 2 of those. Okay. Next, let's go Place. Let's go to our Motor folder, and let's place in the Never Rest motor. Never Rest motor. Place in 2 of those. Next, let's place in, and let's go to the Wheels folder. And on this one, notice there's part 1, part 2 of the wheel here. That's the center of the wheel and the tread of the wheel. And then there's this one that's the assembly of the wheel. Let's go ahead and place the assembly. You can do that. You can place an assembly in an assembly. It's called a sub-assembly. So we're going to place in this sub-assembly into our other assembly and place in 2 of those for that wheel. One more, we're going to go Place. And this one is under the Clamp Colors tab. Clamp Collars. Not colors, colors. And I don't think you have both of these in here. And I think I deleted the other one out, at least I meant to. You need the 0.25 inch one. So it's the Clamping D hubs tapped. You might not be able to see all the detail of the writing. You might have to open that up a little bit. But it's a 0.25 one. I don't think you have both. Do you have both out there? Oh, you do? All right, I thought I deleted it out. I must not have. So place 2 of those. All right, that's your parts. Okay, so now what we're going to do is we're going to place some motor mount onto this robot. Now, there's some options of ways you can make a robot. You can make a robot 2-wheel drive, 4-wheel drive. You can make it 4-wheel drive with individual motors powering each wheel, or you can make it 4-wheel drive with 1 motor powering 2 wheels. You know, there's a lot of different options. We're going to do ours 2-wheel drive with 1 motor powering each wheel, and then 2 just free rotating wheels that have no power to them. I'll show you some examples of those on the actual frames of the robots, but sorry you can't see that on the video. All right, so what we're going to do is the first motor mount, we're going to go constrain. The bottom of the motor mount is this side where you see the 2 bolt holes. We're going to mate it to the back of the robot. Remember, I always refer to this as the front of the robot? This back here is the back of the robot where we put that extra plate. I'm going to flip this upside down, and I'm just going to mate this right there to the plate. And I'm going to apply that. Then, here's the motor mount here. I have the bolt holes in the bottom of the motor mount. I'm going to put this first bolt hole that's here. I'd have to flip it upside down to see that, but this first bolt hole that's right here, I'm going to mate to this corner of our motor mount. So on the outside frame of the robot, this corner of it to that first hole in that plate, that corner hole. So the way that's going to look is like this. I'm going to flip this upside down so I can see that hole right there, the center line of that hole, to that corner of the motor mount. If it's like mine and it doesn't align there, it's because it's selected on this one that's opposed. We want to go to this one that's aligned. And it should slide right there into place. Apply that. Okay, so now your motor mount will rotate here like so. And I did not state this before. I'm sorry. I should have stated this before. This portion of the motor mount should be back here in the back, and the portion is rotating now. It should be rotating around this axis. I did not state that specifically before. But we don't want it, if it's flipped around 180 degrees, I just want everybody's to be the same. And you'd want to do it the same on your robot too on both sides. So if you did that wrong, undo that constraint if it's on the wrong pivot point and move it to here. All right, next. I rotate this off just a little bit off to the side so I can see it. It is going to line up with this hole here, but I got to be able to select that hole underneath. So I pull it off to the side just a little bit like so, flip it up, and I'm going to constrain that center line with that hole and apply that. That's got that motor mount locked into place nicely. So now, we're going to put our motor into that motor mount. So we're going to go constrain, select the center line of your motor to the center line of the motor mount, Now notice mine there, it is facing out. It is facing the correct way. We want the shaft of the motor pointing to the outside of the robot. If yours is facing the wrong way, if it's facing that way, all you do is you hit one of these two buttons. It's either aligned or it's opposed. You have to choose which way you want it to be. You want it to go, whoa, not that way. You want it to go that way so it's facing out. And apply that. Then, next, I want to flush this surface of the motor mount, of the motor, to that surface of the motor mount. So those two are just flush there. So it's sitting there flush on that, just like that. And that's it for now for the motor. We'll get the next step of the motor here in just a second. All right, so now, notice this motor rotates around and around. As I was just showing you on the gears and with the sprockets, what this is really used for is, if you have a sprocket on this or a gear on this and you have it meshing to another one, what you can do is you rotate this around, and notice how it changes the center line of this. It moves it in this direction. So you'd rotate this around until it's nice and tight. Your gears are meshing tight together. And then you tighten your screw here, and it holds it in place there tight together. If you're doing a chain driven, you'd rotate it the other way until your chain's pulled tight, and then you'd mesh this together or clamp this down, and it'd be held in place nice and tight. For us, right now, what we got to do is we just got to get this set into one position and have it locked in place. Otherwise, if you have one motor where it's here in this position, the other motor that it's here in this position, what's your robot going to be like? Is it going to set level? One wheel on the right of the robot might be a half an inch difference from the one on the left. So your robot would be a half an inch taller on the left than what it is on the right, depending on how you have this thing mounted. So all we have to do is you just have to set it straight. The easiest way to do that is get to a view looking straight on it. So I'm going to switch there to the right or left side view. You might be right, doesn't matter. When you do that, you can see the flat spot that's on the shaft. So there's the shaft. You see the flat spot on it. I'm going to go constrain. I'm going to do the second type of constraint, which is an angular constraint. On the angular constraint, it is the first option. It's the directed angle, it's called. So we're going to pick directed angle. I'm going to pick that line. Notice how it puts an arrowhead on it. And I'm going to make it lined up. And I'm just going to pick the bottom of the motor mount right there. And see how that shows me a 0-degree angle? That's perfect because that's all the way down. I could change this if I wanted it to be 180. Well, that was a 189, but 180, it'd spin it around where it's just the opposite and it goes all the way down. I did want it at 0 though, so there it is at 0. We're going to go OK. And now that motor's locked in there and won't move. Let's put a wheel and hub together. You've heard that before. All right, so notice on the hub, it has this cylinder on it. This cylinder that sticks out there, I think it sticks out 2 millimeters, that is designed to stick right into this hole here. So the first thing we're going to do is we're going to go constrain this the flat portion of it here. I want to have it mated to this flat portion of the wheel. Doesn't matter which side of the wheel is mirror image. So I'm just going to click it right there and mount that to there, or mate it to right there. Then next, this thing moves around there. Next, I want to have the center of the hub aligned with the center of the wheel. So I'm going to go constrain. Now this is a little bit tough here. Notice this hole for the hub. It's not just a round hole. It's a round circle with a slot cut in it and a flat spot on it, both. I'm going to make it sure I have this. See the center line showing up? When I hover over top of the arched part, a center line shows up. If I pause there, it's called the axis. So that axis with this axis. And again, not going to do it until I click on this one. It goes a line. And there it lined those up. So I'm good. That's on the center of there. It spins around nicely. The only thing I don't love about it is it does spin around nicely. I need to lock that in position. You need to lock one of these holes with one of these holes. I'll let you kind of play with that on your own. I'll show you in just a moment if you need it. So if you need to see that, here you can see I went over to the back side. Here's my hub. Here's my wheel. Notice how it rotates there. I'm going to rotate it to where it's close, right to there, put it at an angle that I can see, and put this hole of the hub centered up with the wheel. So I'm going to constrain the center line of that, the center line of that, apply it, and it's great. All right, now, I need to put this wheel onto the robot. So once again, the center line of it, so I'm going to go to the center line of the center line of the hub. So I'm going to go there. Remember, you have to pick that special spot to get the center line of the hub. So center line of the hub, the axis of it, lined up with the center line of the motor. Now when you put it there, let's think about this robot if you're actually working on this robot. Would it be easier to tighten this all up and take care of this if the hub was on the outside here, or if the hub is in between here? How's it going to be easiest to get to this little screw? If it's on the outside, it's going to be easy to get to. If it's on the inside, this is going to be so close in there, it's going to be almost impossible to get to. So this one, for mine, I need to flip it the other way. So my hub is sticking out here on the outside. Then I can tighten up this screw that goes right in here. And I'm going to apply that. My wheel will still slide back and forth. We'll put that into place here in just a second. So now our wheel slides back and forth on there. Two things we still have to do. One, the position where my wheel is kind of important. One of those practice robots, one of those example robots up there has a problem. The wheel is mounted about like that. Do you see a problem if your wheel is mounted about like that? Yeah, it rubs here. That causes a little bit of interference here, and your wheel just does not rotate real well. We want a little bit of a gap there. You want it to be uniform. You just don't want to put it out there any old where. I don't want to flush this end of it because that's going to stick it out there awful far. I want it to be a 2 millimeter gap between the frame of the robot and the wheel. And right here is your furthest part out on the wheel. So the way you're going to do that is you're going to go constrain. It's going to be a mate. You're going to mate this surface of the wheel to the frame right there. But I don't want it tight at 0 offset. Right here, notice, maybe you never have noticed this, it says offset right there. I want a 2 millimeter gap there, so we're going to type in 2. And I'm going to apply that. And notice what that did for you. It put a little tiny 2 millimeter gap in between the frame and your wheel. And that's perfect. That's beautiful. That's what you want. Only one more tiny tidbit to do. Notice, again, this wheel spins. Typically, I don't like it, or I don't mind it spinning like that, but on this one, it does cause a little bit of an issue because notice, if we look straight at this again, like we did before, it's spinning here. That flat spot of the hub needs to be lined up with the flat spot on the axle. This way, it doesn't work real well. So you're going to do the same angular constraint that you did just a moment ago. You're going to go constraint, you're going to go to the angular one, you're going to go to the directed angle, and you're going to make that angle line up with that angle. And it makes it nice and straight there. That's beautiful. Fits on that hub nicely. Apply that. And there you go. Your wheel will no longer spin, but that's okay. Now what I want you to do on your own. A lot of you have done this before, and you've mirrored assemblies or mirrored things to the other side. In an assembly, not a good practice to mirror things to the other side or to the other part. Because if things change on one side versus the other, if it's not a mirror image, then it just causes you all kinds of issues. So better yet is you just constrain it all together on your other side. So this is good practice for you. Repeat the steps you just did of putting this motor mount on the other side, putting the motor, the wheel, the hub, all those things on the other side, getting into place the way you just did. Good luck. Make it happen.